Okay, so in this video we're going to be looking at how we can decide which parameters in the regression are important and basically be able to drop those that are insignificant. So here is example 7.4 of the textbook. We were looking at fitting a cubic polynomial to a set of data points and decide each of these terms is necessary. So our approach starts from calculating z-values, z1, z2, z3, until z4. And by doing so, we actually have to calculate a big table like this. I think I have to make it a bit smaller. Okay, so these are our x values, the y values, and then we have to calculate a lot of quantities here. We have to calculate x squared, cubed, to the 4th power, 5th, 6th. We have to calculate x times y, x squared times y, x cubed times y. We have to calculate, after we calculate the coefficients, then we have to calculate the y calc, residual squared, and then y calc minus and then, yeah, so basically we have to calculate y calc, residual squared for now. Okay, so let's see, with this table, we can go ahead and calculate the G matrix. So here's our G matrix. I'm not going to go through the details of it. It's pretty much like other examples. On the right-hand side, we calculate that using some of, the columns here. Using the G matrix, we calculate the coefficients. So let's say these are the coefficients we get. The question is, which one is significant? Which one we have to keep? Which one we have to drop? Okay, so we have to calculate the t-ratio. Now go back to t-ratio. If you remember that, t-ratio is the coefficient divided by the standard deviation of every parameter. And that's exactly equal to, equation 7.28. So we have to calculate the standard deviation. To calculate the standard deviation, we have to calculate the S sub E and inverse of G, right? So we have to calculate this S. So here's the inverse of G. I have it already. Then we have to calculate S sub E. I actually have it right here. So S sub E is going to be, let me see, I think this is the one. Yes, we have, how many data points we have? Let's see, the degrees of freedom here is going to be from 2 to 26. So that gives me 25 samples. Right, from 2 to 26 is 25 samples. And then I have 4 model parameters, C1, C2, C3, C4. So it's going to be 25 minus 4, it's going to be 21. That's why I have 21 downstairs. And then the numerator is going to be a residual squared, which I have right here, 10.9. So residual squared divided by 21, that gives me the SE squared. And then the square root of that goes into, well, actually the SE squared times the G inverse gives me the the S matrix. And, well, okay, so the S matrix, we only keep the diagonals. Let's see, I think, yeah, so these are the diagonals of the S matrix. The standard deviation for C1, C2, C3, C4. Okay, and now we can get the t-ratios. T-ratio is going to be the coefficient divided by the corresponding standard deviation and so forth. So we get the t-ratios for all 4 coefficients. Now we're going to look at the smallest first. The smallest is this one, the smallest in absolute value. And this t-ratio is less than 2. According to the textbook, if a t-ratio is less than 2, that's insignificant. We have to drop it. Okay, if we calculated t-ratio is less than 2, that is insignificant, we can drop it. So the first term we can drop is the C2, which is the linear term. So that tells us the linear term is unnecessary. This is redundant. Okay, that means we get a better fit by dropping it. So we're going to drop C2, redo the whole analysis with only C1, C3, and C4. And just discarding C2, there's no C2 anymore, there's no linear term. We go ahead and redo the whole thing again. Okay, now we calculate, so this is the standard deviation for C1, this is going to be C3, I would say, this is C3. This is going to be C4. We don't have C2 anymore. And this time we get the t ratio of these. Like now, if you look at all of them, they're all bigger than 2, which means all of them are significant, so we're going to keep all of them. Okay, so this strategy shows how we can go about dropping or keeping each term in the regression model. So we're going to start with the smallest first, and look at the t ratio. If it's less than 2, we're going to drop it. If it's bigger than 2, we're going to keep it. Then we're going to redo the t ratio calculation with the new parameters. We look at the t ratio again, and we do the same analysis. If it's less than 2, we drop the smallest one, keep all others, redo the analysis. So we do not drop 2 parameters at the same time. Okay, so keep in mind, we always drop 1 parameter, redo the test. Do not drop more than 1 parameter at a time. Okay, so that was example 7.4. And so anyways, so basically, I think the first fit you see here, this one, I believe is, so the line that you see here, this is with before dropping the linear term, and the one that actually goes through the data points, this is with, after we drop the linear term, you see you get much better fit. So this black line is much better than this black line, because here we dropped, from here to here, we dropped the linear term, you see you get much better fit. It still is cubic. Still is cubic, but it doesn't have a linear term. Okay, so I hope this is useful. In the last example for this chapter, we're going to look at the integration that we, I think, looked at before. So that's example 7.5 in this chapter. Yes, so before we looked at the mean heat capacity of gaseous propane. If you remember, we had this table, I think, in the integration section, and we talked about how we can basically do the fitting. So in this case, let's say I'm going to fit, we have some data points, we have the temperature, we have the heat capacity, and I want to correlate the heat capacity to the temperature using basically a cubic polynomial. So let's say I assume a cubic polynomial. It has a constant term, linear term, quadratic term, and also it has the cubic term. We go ahead and do the same analysis we did here by calculating the t ratio, and by doing so we see that the t ratio is less than 2 for the cubic term. So there used to be a t to the third power with the coefficient here, but because the coefficient shows a t ratio less than 2, we dropped it. So this is the best fit, which is pretty much like a quadratic. So let me show you the spreadsheet for that. So here's the integration for, make it smaller. This is the integration and linking it to the t ratio. So even smaller than that. Okay. So this is the table we had, t, and then the heat capacity, and I'm going to fit a cubic polynomial. So to do that, you have to calculate, the g's and s sub e and s and all that, and calculate the t ratio. By doing so, we see that some of the coefficients are unnecessary. So let's look at the cubic fit first. So initially we consider constant, linear term, quadratic term, and cubic term. And we do all the analysis we talked about. We calculate the g and se and s and all that. And we go ahead and calculate the t ratio for all parameters. So here's the t ratio. For the intercept is bigger than 2. For the linear term is bigger than 2. For the last two are actually not bigger than 2. They're less than 2, the absolute value. So we have to drop. Which one we have to drop? Okay, you don't drop all of them at the same time. We just drop the smallest one first. So the smallest one is this one, the absolute, in terms of absolute value. So absolute value of this is less than that. So we're going to drop the cubic term first. So we get a quadratic fit. So now this time we have intercept t and t squared. We do the t ratio again, and we see that all of them are bigger than 2. So remember, initially, this one was also less than 2. But after we just dropped the last term and redid the fit, this time we see the quadratic actually shows t ratio bigger than 2. And that's why I'm saying do not drop 2 parameters at the same time, just drop the smallest one. Okay, so we dropped the cubic term, we redid the analysis, and we found that all of them now are significant. All the t ratios are bigger than 2, which means we have to keep all of them. Okay, so I hope this is useful. This showed 2 examples on how we can use a t ratio to drop or keep the model parameters. Okay, so thanks all for watching. Stay tuned for the last video on couple exercises in chapter 7.